right. Can everyone, yeah, you can hear me. I can hear myself. So I'm going to talk to you today about, I was thinking about what I wanted to talk about. And I was like, well, what happened when I graduated from university? So when I finished university, I felt like I wasn't a great programmer and that I had a lot to learn. Who feels like they have a lot to learn about programming? Everyone, you're the best. Who isn't always sure what they should learn next or what the coolest thing to learn next is? A lot of you. Okay, so I finished university and I didn't know what to learn about programming. I was I'm not the best yet, but I don't know where to go. So in this talk, I wanted to pick a couple of directions where I've learned a lot about programming since I finished university, and that I think are super, super cool. And maybe you'll think they're cool too, and maybe you'll want to learn more about them. So this talk is going to be in two parts. The first part is about debugging and how to make your programs work when they're totally broken and nobody knows why, including everyone. And how to spy on your programs. And the second part is about performance and how computers are really fast and if your programs are slow, how to fix it. Because I find that super fascinating. You can spend your whole life on it. And it also includes a video of a yelling Australian man, which is important. I want to convince you in this talk, hopefully, that debugging is really hard and an interesting pursuit, and also that it's cool and fun. Who has run into a debugging problem that they totally couldn't solve, even after a week? A lot of you. Who thinks that that's fun? Some of you are with me. Some of you are yeah, that's fun. Some of you aren't. I'm hoping to get more of you onto my side of this is cool and fun and awesome. When you're in this zone where you're oh, this doesn't work, and no one knows why this doesn't work, and I can't do anything, there's only one thing to do, right? Other than hide under the bed and cry, which is also an option, or go to sleep. So what always happens to me is I'm help. I don't know what to do. I go and I get more information about what's going on somehow, right? Maybe I add some print statements, and I'm going to talk about some more weird, sophisticated ways to get more information that have really helped me. And then eventually, I'm a genius. This is amazing. I know everything. And then you realize you have to actually go fix the bug, which is not as fun, or maybe fun. Everything is fun, right? Okay. So to convince you that debugging is hard, I want to tell you a short story about a problem I ran into at work a while ago. So I had two programs, Program 1 and Program 2. And Program 1 was sending a request to Program 2 to just to do something. It's not important what it was doing. And they were both on the same computer, and it took 40 milliseconds. Now, does 40 milliseconds seem fast or slow? Who thinks it's fast? Fast? Who thinks it's slow? Okay, lots of you think it's slow, which is cool, because 40 milliseconds is super slow. It means you do 25 of them in a second, and it was causing a problem that it was slow. And my goal was to make it something 1,000 times faster, right? And I was okay, so it's really slow. I want it to be 1,000 times faster. What next, right? And I asked some of my really smart colleagues. I tried to read the code. The code was not helpful because it was just send request, get reply 40 milliseconds later. And then the thing that it was sending the request to was not having a problem. It was written in a super fast programming language, it was in Go. Everything was perfect. It wasn't having any problems. Nothing was wrong. So what can you do? So what you can do is you can go get more information, right? But it wasn't obvious how to do that because there was nothing, right? There was no more information to be gotten. It felt so at the beginning, for the first program, it looked Program 1 was hey, you'd wait, and then the second program would be oh, hey, right? So it looks the second program. Who thinks that the second program looks slow in this example? Maybe you agree with me. I thought that the second program was the problem. But then, and I hope you can read this. So I started out thinking that the first program was the problem. But then I looked into it more, right? And I used some magical spy tools, which we're going to discuss in a moment. And then it turned out that the first program was sending one packet of information, right? And then 40 milliseconds pass for no reason when just like hanging out. And then it sends the second packet. And then program 2 actually replied right away once it sent the second packet. And so this was really cool to know. And then it turned out that we needed to change like a network setting on the first program. And then my coworker was like, okay. And then I was like, it totally worked. Everything is fast now. And then people were like, you're a wizard. They actually said the words, you're a wizard. Which made me feel really good because like I changed the TCP setting and then I fixed everything in the universe, or at least this small problem. But the point is not that I'm a wizard, right? Because I am not. I am only human, like all of you. And the point is that like I had these really cool tools that I was using that other people weren't using because I loved them, and then it helped me solve the problem. And so I wanted to use some of these tools so that you can also be wizards. So the tools I want to talk about are all what I like to call like black box tools, where you have your program and you pretend that your program was written by like a malicious like evil gnome who's like out to get you, and you just like observe it at a distance with like care. And so all these tools I'm going to talk about don't care which programming language the program is written in. They don't need the source code, and they're like super useful. I'm going to talk about maybe 3 tools like this, but there's kind of a universe of them. Who believes that this is? Who knows that this is possible? Some of you know. Who doesn't know that this is possible? Like, who thinks that you need the source code to like debug a program? Maybe some of you think that. Maybe you don't want to say because I'm going to tell you that you're wrong, which I understand. And maybe I'm being a jerk. But anyway, it's totally possible. And this like blew my mind when I figured it out like 2 years ago. So, outside the box is like, so like operations that a program can do are like, you can open the files, you can kill programs, you can write to disk, you can like start a DDoS attack, right? And these are all things that like affect the world outside of your program. And internally, things that happen in your program, which is what we're not going to be able to see, is we're not going to be able to see like, things like function calls or like memory accesses. We're not going to see our program be like set a variable. We can only see like it doing things like opening files. And then I think it's like kind of intuitively clear maybe what the difference between like inside and outside is. But when people started telling me like, hey, there's like actions your program takes, I'm like, well, how do I know like why is setting a variable different from like opening a file, right? Like what's the difference? And the difference is that if you open a file with your computer, with a program, programs don't actually know how to open files, right? Like, so to open a file, can someone tell me something that needs to happen to like read a file from disk? Can I get you to yell something? System call. But like, what does the code need to do? Like, it needs to talk to the hard drive. Does it need to talk to the hard drive? It needs to like read the file system, right? And your program doesn't know how your file system works, but the operating system knows how the file system works. So what you do is you ask your operating system how to do things. And those are called system calls, as everyone was saying, because you're like way ahead of me, everyone. These tools that I love, they all ask the operating system to like act as a spy for you, right? Like your program is like, hey, I'm opening all these files, and like I'm spying on you and sending all your data to the NSA, and the operating system knows, right? No matter what your programmers are doing, the operating system knows, and you can just be like, hey, I don't really trust that program, right? Or like if I read the source code, I don't trust that I wrote it right. So please just like report the activities to me. So a couple of the tools we're going to cover, the bottom left is missing for some reason. We're going to talk about strace and dtrace, which are kind of for everything. And then we're going to talk about some specifically like networking tools for debugging network problems. And then we're going to talk a little bit about files, depending on where we are time-wise. So, I don't like reading man pages. Who really likes reading man pages? Do some of you really love reading man pages. That's the best. I like to tell stories. So here's a story called "The Case of the Broken SSH Key," where I wanted to SSH to, let's say I wanted to SSH to a box that I have, right? And I'm like SSH whatever.com, and it's supposed to work, and then it doesn't work. And I don't have the source code for SSH, right? So I'm like, I don't know what's going on. So I'm really sad. And we're going to use strace to solve it, right? So the important thing to know is what's strace, other than my favorite thing in the universe. So strace traces system calls. So when you SSH to whatever.com, it needs to open something called the SSH key, where you're like, this is like my password for like connecting to the server, right? And then it needs to actually like send and like have this conversation with the server, and then it needs to like wait for the reply and like send data back and forth. And in order to do all that, it needs to tell the operating system, right? So if I want to know why SSH isn't working, I can ask the operating system, well, what did it ask you to do? By asking it what all the system calls were. Using strace is really easy. You just do strace and then the program that you want to do, that you want to run. And when I did this, I found the culprit pretty quickly, right? I was like, oh, you're trying to open my SSH key, and it didn't have permission, right? Which is, I might have guessed because like I've had problems with this program before, and this is what they were. But if I couldn't guess, then I could just like go look at strace. So, and then the solution to this problem is just like change the permissions, right? You can be like, please make it so that like SSH can actually read this key file. So strace is Linux only. Something that's super important to know about strace is that it can slow your programs down up to 50 times. And it's my favorite thing. I use it all the time to like debug kind of like general purpose programming problems. One thing I used it for yesterday is I was writing this Java program, and I wanted to know like what the command line incantation to start this program was. And like there was another program that knew how to start this program, but I didn't know how to start it. So I want to show you. I used strace to do it. And then it turned out that it was this thing on the screen, which you cannot read. But it's like, it was like this like huge monstrous like command, right? Which I was never going to guess. But then I was like, strace, just tell me what that command is. And it knew. And I was so happy. Because then I didn't have to like read any stupid documentation. Like, I hate reading stupid documentation. I love using strace. Another thing that you can use strace for is like if your program is logging information somewhere, you can just, and you don't know where, because again, like you haven't read the documentation, like me. I have a lot of conversations with like people where they're like, "Did you read the documentation?" I'm like, "No." Who does that? And so you can strace the program and be like, where is it writing that log file? And then it'll just tell you, right? Like, it's so easy. Strace, I want to warn you that it looks a little scary when you run it. I want to see, maybe I can like point at some of this for you. So, can you see this? Oh man, that's totally legible. Cool, great. I won't try to explain that to you then. Like, can you see this at all? No. Oh, cool. Great. That's good to know. Can we? I could try to switch my terminal colors. Let's do that. Oh man, live demos. View. Edit. Profiles. Colors. Is that legible? You all shouldn't bear with me. Right, this was the command line incantation. And then I'm just going to trace something right now. So if I want to run Google Chrome, I can just do trace Google Chrome. And then it's like blah, 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 blah. And the piece of advice I have for you when looking at stuff like this is to mostly ignore it. Because, like, what even does this mean, right? Like, what is mutex? I mean, I kind of know now, but, like, no. Just pay attention to the stuff you understand, right? Like, it'll say open here sometimes, right? Open. We know what open means. It means it opened a file. And then, like, ignore everything you don't understand, which is going to be mostly not, right? I love strace so much that I wrote a zine about it, which is like a 8-page fanzine about how much I love it. I didn't bring them with me today, but I'll be here tomorrow, and I'm going to bring them tomorrow. So if you are excited about strace, or you're not excited yet, but you think that you might be, come talk to me tomorrow, and I can give you one. It has my favorite system calls. Okay, so strace is Linux only, which may not be helpful to you if you use a Mac. If you use Windows, I don't know anything about Windows. I'm just hoping that you use a Mac or Linux. Windows is fine. I just don't know. If you use a Mac, you can use a program called dtrace or dtrace. Dtrace is actually even better than strace. It doesn't slow down your programs when you use it. It's way more powerful. I found a couple of examples of things it can do. Can you read this? No. Cool. So one thing it can do is you can just be like, I'm worried that my programs are spying on me. Just tell me all programs that are reading files from /home, right, from my home directory. And just let me monitor that all the time and just make sure. Or another thing you can do, which you can't read here, is you can find out all system calls that have errors, right? And be like, please tell me every time that there's an error, anywhere on my computer. I just want to know all about it. And dtrace is sure. So it can do more complicated stuff, and it's really great. I polled people on Twitter to ask if learning dtrace was worth it, because it's a little bit more of a learning curve. And everyone was like, yeah. It's the best. I spent a few days learning it, and I learned a lot, and it was super fun. So that's my really biased Twitter poll, because I think the people who I talk to on Twitter are also likely to dtrace, because anyway. I get really excited. But I have a new mystery for you. This one is called The Case of the Turkish Website. This thing in the corner is, with my really great drawing skills, supposed to be a cup of tea. But that's actually what teacups look like in Turkey. Anyway, you can't tell. It's fine. So in this mystery, I go to a website in Chrome. And it's hello world. And then I go to the same website in my terminal, and it's in Turkish. Oh. So we're going to use a tool called ngrep that's going to solve everything for us. So people use grep. Do people use grep? Some use grep. You can use grep to search files for data, right? So if you want to search files, you can use grep. If you want to search your network traffic and everything that's going through your network, you can use ngrep. And it's the best. And you can be like, I'm in your packets. And it's the most fun. So because you won't be able to read that, we're just going to do a live demo, because we know that goes well. It's going to work. You'll see. So I started ngrep, and it's not doing anything yet. And then I go visit my website in Chrome, right? And it's as predicted, it says hello world. And then we can see the request that got sent by Chrome, right? We can see what Chrome said. And then if I do it in my terminal, which I'm going to do in a really tiny screen that you can't see, it makes a different request. It makes this request. So you can see the curl request is pretty simple. It's get hello. Can people read that where it says get hello? Okay. HTTP 1.1, user agent curl, right? So curl is just like, I don't know, just give me the website, right? But Google Chrome is pretty different. It's like, I have a lot of feelings about how you give me this website. It's like, get hello, HTTP 1.1, host, blah, 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 connection, keep it alive, application, oh God. So Chrome has, and in particular, at the end, it says accept language, ENUS. Let's reload it one more time. Yeah, it says accept language, ENUS over here. Which, because we can use our brains, is we're like, well, we're having a problem with our language. So maybe, because like, the only reason that the server is sending back a different response is because it got a different request, right? So if I ask curl to send the accept language header, then it sends it in English instead of in Turkish, which makes me really happy because now I can actually read it. Also, I apologize if I got the Turkish wrong because I used Google Translate. So I probably did. So we totally won. You might have other questions about ngrep. Like, for example, let's say your packets are encrypted, right? Like, I'm going to try to do another demo. Like, let's say I want to look at what I'm sending Google, right? So I start doing ngrep for Google, and then I go to google.com, and it's sending me some stuff, but it's sending me a lot less than I would actually expect. If I try to search for, like, let's say Y Combinator, and then I go to like Hacker News, it's again kind of sending me less. Like, I'm not seeing any HTTP requests here. Do people know? It probably already said on that slide, right? Did it? Yeah. So this is because the packets are encrypted, right? So if you have encrypted information, you can't grep it because it's encrypted, right? Like, that's the point. So other people can't spy on your network traffic, but you yourself also can't spy on your network traffic, which sucks. So you can use this thing called MITM proxy, which is actually, like, I think, really well documented and really relatively easy to use. And then that can let you spy on your encrypted traffic too, but not on other people's encrypted traffic, because that's the point of encryption, right? If you want more power, and this is then you can use something called Wireshark. I bet this is going to be totally invisible. Is that true? Okay. Let me go look at it. So I'm gonna start like capturing packets, and then I'm gonna see if you can read anything. Okay, cool. You can read just enough to see that this is like really complicated. And the reason I wanted to show this to you is sort of to convince you that it's really complicated, but also like, oops. It's like something that you can potentially understand. I don't know if this is going to work. Okay. Boop. Will this work? Demos. Not really. Okay, cool. I give up. So Wireshark is like, I really like it just because it's like a graphical interface. You can click on things. It's a little bit hard to approach at first, but like you can apply like the S-trace principle of like ignore everything I don't understand and just look at some of the things I do, and that can take you a long way. I want to say a couple of things about debugging, and like how I got better at debugging, because I started out. I think I'm pretty good at debugging now. I used to be really bad at it, and I would get really frustrated. And I think what changed for me is like I started remembering that like when a program isn't working, that there's a reason for it. Like it's not just like trying to like make me sad. Like there's like a logical reason. Because often people are like, oh, you know, these things just happen, right? Which is not true, right? Like these things do not just happen. Bugs happen for reasons that you can find out with your brain often. And then the other thing is like as I got better, I started to get like more confident. I was like, okay, this bug is happening for a logical reason, and like I can totally fix it. I think definitely. And this like to do things like spend like 3 weeks fixing a bug, because it's important, right? And as I learn more about how computers work, I can be like, okay, I'm having a problem with my network. Well, I know that uses TCP. Okay, and then if I understand more about networking, I could look at Wireshark and I understand how it works more, and that helps me fix problems that previously I wouldn't have been able to fix because I didn't know what a system call was. I use strace a lot of the time, and I really like it now. Because sometimes when I write a program, I'm I know how to write programs, right? I can write a program and it works mostly. But then when it doesn't work, that's I can learn something and it's so fun. Okay. I want to tell you about computers being fast now. This is going to be fun. So yesterday at work, it was very opportune because I wanted to talk about performance today. And someone was like, hey, Julia, there's this box, and it's processing 100 requests a second, and it's having trouble. So is 100 requests per second fast or slow? Is that a lot for a computer to process, or not a lot? Who thinks it's a lot? Who thinks it's not a lot? Depends on the request also, right? But you're saying it's not a lot. I think because I told you computers are fast. But it's actually not always clear to me, right? Even yesterday, I was like, is that a lot? So I wanted to explore this question of whether or not 100 requests per second is actually a lot, and in what way it depends on the request. I have some propaganda around computers being super fast. I made a game about how fast computers are at computersarefast.github.io. I'm going to have the link to that again later. And what we do in this game is we give you a program, and you're like, how much do you think this program can do in a second, right? How many bytes can you search with grep in a second? What's the answer to this? How many bytes can you search in a second if you don't have to read it from the hard drive? A megabyte? 10 megabytes? On this laptop, 3 years old. Oh no. Oh no. How many? 10 megabytes. I want another guess. 100? 100? A gigabyte? A million? A million gigabytes? 100 gigabytes? Who thinks it's 100 gigabytes? You're not sure. I wasn't sure. It's 2 gigabytes. So you can search 2 gigabytes in a second. Similarly, if I want to just add up bytes, and I'm byte plus 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 plus, I can do 6 billion bytes in a second. And in some sense, this isn't really surprising, right? Processor speeds are measured in gigahertz, which means they can do billions of instructions per second. So kind of broadly, you should be able to expect to do billions of things in a second, right? No big deal. Though this was really surprising to me the first time I found it out. I was like, you could really do a gigabyte in a second? A whole gigabyte? No way. But okay, so that's just adding up bytes, right? That's not a real task. So let's say I wanted to serve HTTP requests, right? And I have a web server. And let's say I'm doing something pretty simple, and also that it's in C. How many of those can I do in a second, do you think? 1 million. Great, you're so good. It's 1 million. Which was also crazy because I was I'm having trouble doing 100. What do you mean you can do 1 million, right? And it's in C, but even so, I was kind of mad. Okay, so what if you use Java, right? We use Java. Who uses Java? Okay, Java. How many can we do in Java? 1 million? I'm not sure. You could definitely do 200,000. Someone I know did 200,000. You can probably do more. Anyway, there are people here who know if you can do more. But you can definitely do 200,000. What if I use Python, which is kind of slower? Did someone say 50? That's so pessimistic. But like probably like at least 1,000, right? Like it can't be more than 200 times slower. 100 doesn't look like a lot. What's wrong? Why can't it do it? And then obviously, like you can make your computer slow, right? But like, how can you make it slow? So there are two ways you can make your computer slow. One, you can use too much CPU, and two, you can just be like waiting for stuff all the time, right? Like this is like logic, right? Either you're using too much CPU or you're not, and you're just like doing nothing. And doing nothing is a surprisingly common state to be in when your computer is slow. So I have a short story about using too much CPU. I also have an opinion about this in my experience, which is that like slow programs, when like either because you're using either for like CPU reasons or not, are often like for me just like misunderstandings. Like where like you thought you told your computer to do something and the computer was fast and then like there was a miscommunication and it got super slow. And we're going to see how that plays out in a second. So I had a program at work that was written in Java, which as we know, really fast, millions of requests, 200,000, a lot. You can do so much stuff in Java. I was trying to process millions of records. It was taking like 10, 24 hours. It was a disaster. I was so sad. It was like in my team's way. It was the worst. So I was sad. And I think this is an important, and not only because it's cathartic, but because it like motivates you in like the possibly like weeks of like confusion to come, right? As you're just like, no, this will not stand. And then people told me a bunch of like cool ideas about like why it might be slow, right? They're like, I think it might be because it's reading too much from disk, or there's some function, or maybe we have too many objects. People have ideas about performance, including me, right, are normally wrong, right? Like all of the ideas that people had to start were wrong, not because those people are dumb. If you asked me why your program is slow, I would also be wrong, right? I would probably say something, I'd be like, I don't know, maybe it's the blah, 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 right? And I would almost definitely be wrong. So the second thing we did was we profiled it, right? And a lot of you probably know about profiling. And we use this program called Visual VM, which can tell you what you're spending your CPU time on. It's free. It comes with Java, and it's like so useful. I was kind of surprised that there's a tool that just comes with Java that does this. And I found out that the culprit was this function called dent HLL $x $6. What? Not helpful. And then like there was this like whole loop, which you can't read, but it doesn't matter. And I was like, okay, there's like a while loop. And I like talked to my partner about this, and we were just like, I don't know, it seems fast to me. Like it shouldn't take a millisecond. A millisecond is like a year of computer time, right? Like you can do like 1 million instructions in a millisecond. So like, why would it be slow? And then we found out about java.lang.math.pow. So java.lang.math.pow lets you take like 2 to the n, right? This function is a disaster. It's like the slowest thing in the universe. It's implemented in Java. The reason it's so slow is that Java wants it to work like in a cross-platform way. So it can't use like the like primitives that like the floating point primitives that you would normally want to use to like calculate powers. So it takes like just like 100 times longer than it needs to, or like more. Like it should take like a nanosecond, and it was taking like way longer than a nanosecond. And so the misunderstanding in this case was just like, you don't want to spend like 90% of your CPU time computing powers of 2? The same ones also. Like there were only like 200 different powers of 2 that we were computing, and it was always the same ones, and we were spending the whole time doing that. And it was like, oh, well, that was a misunderstanding. Sorry. And then everything was like 1 million times faster. It was the best. There's another tool which I really love to do this kind of work called perf, which is like, what am I spending all of my CPU time on? And it gives you these really pretty graphs that are orange and red, which you probably can't read. But it tells you like which functions you're spending the most time in. So the second reason that your program can be slow, other than because it's using too much CPU, because you've had like a misunderstanding, is you're spending all of your time waiting. So let's talk for a second about waiting. So if we have like a database query that's slow, then we want to know if it's waiting or not. I want to show you a tool called Time, which I really like. I like it because it's like kind of really like because it's like super simple. So I'm going to show you a little demo. Okay. What do you mean permission denied? It's okay, I got it. Okay. So there's one very small thing here. Oops. So I run this program, then I run it again, and then it like takes a really long time, and then it's like, oops. Oh, worst. Okay, anyway, it doesn't matter. It says that it spent 4% of its time on the CPU. 4%. Which means that it's waiting. What is this program waiting for? How could I find out? What could it be waiting for? Disk? Could be waiting for disk. Let's find out if it's waiting for disk. We're going to run a program called dstat, which tells you like about disk activity right now. And then we'll run the program. And then if you could read this, you could see that it's like writing like 20 or 30 megabytes to disk every second. Can you read that? Yeah? Like, so it's printing out these lines where it's like, I'm writing 30 megabytes to disk. And you're like, oh, I guess that's why you're slow. Like, that was simple, right? So we can use time to figure out, like, are you waiting? What are you waiting for? And like you said, figure out, like, it's the disk. So hard drives are, like, super slow. And networks are even worse. And now I have a video for you about how, like, hardware is important, and it's good to think about what you have in your computer when you're writing programs. Oops, where is it? Okay, this program is called Shouting in the Data Center.
Hi, I'm Brendan. We're here in the Fishworks lab. Sorry for screaming, it's very loud in here with the air conditioners and servers all around me. We just made an interesting discovery and we thought we'd show you straight away. So over here I'm measuring disk I/O operations broken down by latency. I've also drilled down to disk I/O operations taking at least 520 milliseconds broken down by disk. This is using dtrace so I can do performance analysis of disks. I'm applying a write workload to 2 JBODs, which are over here. The lights are blinking on these JBODs because they're doing work. What I'm going to do is not recommended. This is not supported. Do not try this at home.
So you see that spike? That spike is the hard disk being like, what the hell?
This is not special effects, this is real. What we're looking at here is the effect of disk vibration. Vibration is a serious issue, and we can see the effect here that it's caused. So here, the latency for the disks that are under the workload has gone up. Here I can see which disks have now had I/O operations longer than 500 milliseconds, and I can find out that they belong to the JBODs I was just shouting at. So, amazing stuff. This has been made possible by analytics from Fishworks, which lets us look at things we've never seen before. Disk latency, high latency caused by vibration is a real issue. You've seen it. It does exist.
Just don't let Brendan shout at your disks.
That's right. Don't shout at your JBODs. They don't like it.
Okay. So I find this video really delightful, obviously. But I think like the reason I find it so delightful is because like it's about how your hard drives are important, right? And about like how like the performance depends on like actual computers, and like if you were like running like a web server on top of those things while like Brendan Greg was yelling at them, you would have a problem. And you can actually like have these graphs, right, to like measure like what your actual problems are, which makes me really excited. I want to talk about some speeds for a second. So my CPU, we decided, can process like 6 gigabytes a second or something. My hard drive seems to be able to do like 50 for some reason, even though it's supposed to be faster. I don't know why, but it can do 50. That's the real life. And then my network can do like 2. And this is important because like if you're running something like a database, well, this is important. So I used to like not realize that I spent a lot of my time waiting for hard drives, because I was like, well, I thought I spent my time waiting for like a CPU, or like because we were calculating something. But it turns out that we use databases a lot. I use databases a lot. And database is like a software system that lets you wait for a hard drive, right? That's what it's for. It's for reading stuff from disk, and they work really hard to like optimize how much time they spend reading from a hard drive. But the basic conversation that you're having with the database a lot of time is you're like, I would like data. And it's like, okay, I will read 100 megabytes from disk. You wait. And you're like, please faster. And it's like, lol, use an index. Like, you get what you ask for from the database, right? And if the database is on a machine where it can read like 50 megabytes per second from its disks, that's all you're going to get, right? Like, it just depends on the disks inside the machine. I think it's easy to kind of forget that like the performance of the things you're working on depends on like the actual hardware inside of the machines that you're running on, right? And that like if you don't have fast disks, or if you only have one, it's just going to suck, right? And there's no way around it. If you want to wait less, there are a couple of ways to do it. You can either do less stuff that makes you have to wait. Like you could read less from your disk. You could make less network requests. These are both, I think, really good options. But at some point, you do actually have to do those things to write programs, right? Like, what's the good of a program that doesn't communicate with the outside world? And the other thing you can do to wait less is you can multitask. So you can say like, okay, I'm making a network request, and then while we're waiting for that to happen, we're just going to move on. What language is really good at multitasking? Erlang, cool, advanced. I was going to say something else, which is JavaScript. JavaScript is awesome at multitasking. That's what it's all about. Erlang too, but JavaScript is in my browser. Because JavaScript is like, well, all I do all day is make network requests. So you make a network request, you're like, okay, I'm going to tell you, you set a callback, you're like, this is what has to happen after. But you just, JavaScript always keeps going, right? It doesn't like wait around and like just be like, well, I'm waiting, so I can't do anything. It's like, I'm waiting. I can do everything else, right? And this is what makes JavaScript so good for doing a lot of like web development, right? This is why people use Node.js, is because it's good at multitasking, and that's like really built into the runtime. So the conclusion I came to about this 100 requests per second program, even though I don't know why, is that it's too slow, right? Like, it should be able to do more than that. And I'm going to make it. I don't know how yet. But like, we said that a millisecond isn't fast, so if it can do 100 requests per second, and there are 4 cores, that's like 40 milliseconds per request of like CPU time, because that machine is like at 100% CPU. That's way too slow. It's a disaster. And learning more about how fast computers are has like really like raised my expectations for them. I'm hoping you'll also raise your expectations for them, and that you'll be like, yeah, my computer should be like so fast. If my program is slow, that's not acceptable. A way to raise your expectations is to play this game at computersarefast.github.io. I think it's on my website. I hope so. Performance work and like also debugging are actually really hard. This yelling Australian guy is not only a yelling Australian guy. This is also his whole job. He works at Netflix. His name is Brendan Gregg, and he spends all of his time doing performance work for them, and I'm sure they pay him like lots of money. And he like writes books about it. He like posts like really excited blog posts where he's like, guys, the like ftrace framework in Linux is getting better, and I'm going to be able to measure the blah 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 with the TCP. And I'm like, cool. And yeah, but it's really hard to do. But it's not so hard, right? Like you can learn how to do it, and you can also learn how to do a little bit of it, right? Like we can just like use DSAT and be like, well, this is using a lot of disk. I guess that's why, right? Like it doesn't need to be like super complicated. There are a lot of really good tools out there to do performance analysis and to like also understand why your programs aren't working. You can use them all today. They're really exciting. It's really paid off for me to learn about this stuff. And then you can like become a better programmer and a wizard. And I've become like, and like the way I've learned about all this stuff is I've just been like, why doesn't this work? And then like I think repeating that, like the first time I ask that, people are always like, that's it. Like it just like seems like a dumb question. It's really obvious. And then by the time I get to the third question, people are just like, whoa, I have no idea, Julia. So I've learned a ton just by being curious and also excited about computers and how great they are. We're gonna do questions. You can actually just come up here and ask me questions. I write about this a lot on my blog. You can email me questions if you want. Like I will answer an unlimited amount of email because this is like my favorite topic. Yeah, thanks for coming.